Well, thank you very much. Today we will be talking about causality and causal ML here at Microsoft. I'm Juan Lavista Ferrez, and I'm the Vice President and Chief Scientist at Microsoft AI for Good Research Lab, working in different AI for Good scenarios. I will let the people in the panel introduce, but we will be talking today about causality and causality and machine learning here at Microsoft. Sonia, do you want to introduce yourself?
Great, thanks, Juan. I'm Sonia Jaffe. I'm a senior research economist in the Office of the Chief Economist at Microsoft.
Mingji?
Yes. Hi, my name is Mingqi Wu. I am the principal data scientist at Xbox. I'm leading the personalization journey for Xbox and also do a lot of causal inference to help leadership make a decision for Xbox strategy initiative.
Thank you. And Merrouche?
Hi, my name is Marnus Sameki, and I'm a senior PM on the Azure Machine Learning Responsible AI tooling team, working on tools for understanding models and also making data-driven decisions using causing analysis.
Well, I will start the first question related to like understanding cause and effect for Microsoft is key for us to innovate, and of course we have a big randomized control experiment platform that is EXP. But a lot of times we need to use, there's no way to run control experiments and we need to use observational studies. So the first question for Sonia, and people can chime in too, is what are the most common observational studies techniques that you use or that you see that people at Microsoft are using? And what are the caveats, assumptions, or things that we need to consider for those tools?
Yeah, so I would say the most basic one would be kind of difference in differences, building on that, or synthetic controls when there's not an obvious, straightforward control group. And then things get more complicated with double ML, and I think other people can talk more about the machine learning approaches. And I think that the caveats are all around kind of how good is the control or comparison group of can you think about whatever outcome you're looking at, what are the confounding factors because you haven't been able to randomize into your treatment and control, what factors are going to potentially drive spurious results, and whether you can control from them directly or look at a subsample where that's going to be less of an issue, or use something like synthetic controls to try and balance it out across your treatment and control groups. But I would say kind of all of the techniques and the caveats are all around getting as good a comparison group as possible, right? So saying if we hadn't done whatever treatment we want to evaluate, would this group really have truly looked like this other group, and getting rid of things like self-selection and other confounding variables.
Minji or Marouche, do you have anything to add on that side?
Yeah, so for Xbox, the two key methods we use for causal analysis, one is the difference in difference, the other is the matching method. So these two methods basically help us a lot in the observation study. And the caveat from my experience, other than the methodology-wise, I think the most important thing is working with the domain expert to identify the covariates. So just give you an example. For example, when, last year we start to investigating account linking. So the case is basically there is an existing feature in Xbox platform. The gamer can link their account with external social network like Facebook, Twitter. So we observe the effect that when people link their account, they are more engaged, more social, and revenue generate more revenue. So are this causal effect or is some random things? So we start to do causal analysis. This is not possible to do a randomization experiment because the feature exists already, and it doesn't make sense to stop the feature. And then we use the matching method. But one thing we found is for matching method, the number one, you need to identify the covariates that also impact the response variable. But one of the things is the revenue as the matching input covariates. But if you don't working with in the gaming industry, probably you just directly matching user profile by their annual revenue. But I can tell you from gaming domain expert input, So for gaming revenue, there are basically three parts. One is the base game. You purchase a base game. Second is the subscription, like Xbox has a Game Pass subscription. It's something like a Netflix subscription service. If you pay a monthly fee, you get exposed to, say, 200 games. You can play them for free. Subscription revenue is second. The third one is the add-on stuff. So if you buy a base game and you play the game and you want to buy some add-on features, and this is the three different revenue component from the total revenue. And I can tell you, the person purchased the add-on features versus people purchased the base game, and versus people pay for subscription. Their behavior is totally different. So if you don't working with domain expert, you may not get those insights. So you may not identify the right features for your causal analysis. So that's some caveat of experience I have learned in my area.
So on the ML part, I would love to ask a question to Manoj. So I'm seeing some common misconceptions when people are using explainable AI tools like Sharp or Lime, for example. And sometimes I'm seeing that people read directly, they interpret that the results from these tools are causal, basically. Do you see these, or do you have any guidance for team using these type of tools?
Very great question. We see that all the time. In fact, interpretability via SHAP, Lime, and other techniques was one of the first projects that I started working on when I joined the Responsible AI tooling team. And the very first observation that I had was, wow, people use a machine learning model to model something that they would like to kind of have an action plan for in the real life, and then they go to things like regular prediction what if analysis to kind of figure out, if I say in a healthcare scenario, if I ask this patient to do more exercising or reduce consumption of meat or this or that, how that would impact the real world chance of this person getting, say, a particular type of cancer. This is extremely dangerous because when we have machine learning models, there are a lot of correlations that might have among features. And so when you do prediction what if and change the values of one feature, you might see some changes in the prediction. However, it might not translate to the real world change that you would see by applying that treatment. And so one major thing that I always try to evangelize, and that's why I started my collaboration with the causal team, is interpretability is a model debugging tool, is a tool for understanding your models, how it has made its predictions, based on what factors it has made its prediction. However, correlation is not causation, and so if we really want to understand how changing one factor would impact the real world phenomenon, that's when we have to do sophisticated causal analysis with the appropriate recognition of what are heterogeneity features and treatment features, etc.
Let me ask a follow-up question on that. Do we think that we have a branding problem on the word explainable AI? Like a lot of times when people look at explainable, there is some causal relation with explainable. I was like,
that is a very great question. Yes, I believe that this term is a little bit too general for the purpose of what we mean as machine learning interpretability. All that explainability is that this is not a black box model anymore. I can explain what is happening inside it to a stakeholder, and so that stakeholder can decide whether they're allowing me to go ahead and deploy this machine learning model, versus explaining to the provider of end user solution to end user, or to the end user himself or herself, as what they should do to see an impact change in the real world. And so one thing that I always recommend is, sometimes it is helpful to use interpretability techniques. For instance, sometimes people use interpretability techniques, in context of causal analysis. Sometimes people use interpretability techniques and they can look at top key important factors impacting model prediction, and they get ideas as, which of maybe these features I can then take to a causal analysis and use as a treatment and see whether causal analysis kind of like supports what the interpretability is telling me. So it could be like a proxy to provide some insights about, oh, maybe these factors are worth to try as a treatment via a sophisticated causal analysis approach and see whether they will move the real world phenomenon, but definitely not in place of it. So we should always distinguish model debugging and taking actions and making real world decisions, and not interchangeably use the tools in these scenarios.
Yeah, I fully agree. And I think we went from correlation doesn't imply causation to predictive power doesn't imply causation, and now it's explainable AI doesn't imply causation. So I'm seeing that. So let me go back to Sonia. Sonia, let's say there's a lot of teams at Microsoft that want to start using observational studies. Do you have any lessons learned or anything that you would like to share to someone that is just starting on this?
Yeah, I mean, so actually, one thing that Ming Chi's comment around not wanting to experiment with this feature that was already deployed reminded me of is another technique that we have used is kind of around nudges or promotions. So it's kind of in between the experimental methodologies and more causal or focused methodologies. Whereas if you may have a feature that is available to everybody, right, you're not A/B testing it, but if it's not widely used and you promote it or nudge a random set of the population towards using it, then using instrumental variables, you can actually get at the causal effect, not just of your nudge, which is kind of the experimental part, but of using the feature, which is the causal inference technique part. And so I think that a lot of the time when a team wants to use an observational study because they feel like an experiment isn't an option, in some of those cases, kind of the first line to check is like, is there a possibility for using some kind of promotion or nudge experiment that gets you back to the randomization? And then when that's not possible, I think that, yeah, just the combination of the really important domain knowledge from the team, again, that Ming Chi was talking about, and then the statistical techniques to try and do as clean a comparison as possible, focus on the areas where there's less likely to be selection issues, and get comparison groups that are as close as possible to the treatment group.
Right. Let me ask you another question to Mingji. Like a lot of times, people think that sometimes I'm worried when people are starting to learn observational studies technique. Sometimes I worry that people see them as a replacement of randomized control experiments. And I have seen them used in cases where they could have run an experiment and they still choose to use an observational study. Do you see that in Xbox, or do you have any lesson learned for those individuals that want to start using observational studies?
Yeah, okay. I can give my personal opinion. Maybe it's biased. So my thinking is the golden rule is if you want to prove something causality. So the golden rule is doing a randomized experiment. As long as you have the chance, there's no one can dispute your randomized online experiment result. But for causal analysis, even different researcher will have different methodology, may reach different conclusion. But when something happens, sometimes you cannot do randomized experiment. So causal inference is our goal for tools. So in those scenario, I want to share some. I want to add on something Sonia just said. I think for causal analysis, you don't want to start just look at the data, identify correlation, and start to do causal analysis. So my number one suggestion is identify the right problem. The right problem can map to your organization's OKR. We call it key KPI, so the key performance indicator. You want to map your causal analysis problem to your organization's goal, such that it can take, if you identify causality, the next step you can initiate the next action item to move the needle. So identify the right problem, form the correct hypothesis is even more important than solve the problem. So that's something I want to share.
That makes sense. Marouche, you're working on tools and different applications. Can you tell us anything about what you have in the pipeline of different tools?
Yes, that sounds really great. So, you just saw an Economel demo, which is basically an open source toolkit by Microsoft Research around causal analysis. And so we are going to release a dedicated dashboard for that, which is going to have a variety of capabilities around causal analysis in the UI form. So you can kind of use our URL and our SDK and our dashboard to get a sense of aggregate causal insights, like overall how changing a particular treatment would impact a real world phenomenon. You can look at individual causal insights as for this particular patient or for this particular house, if I change the treatment, how that would impact the price of this house or the health of this patient. And it also has some customized policy that it can offer to you in that sense that, oh, for patients age less than this or the health situation this in this category, then that's the best treatment to apply if you want to see the biggest boost in their health, etc. So we are releasing this causal analysis dashboard as a part of our bigger responsible AI dashboard, which also has model error analysis, model interpretability, model fairness assessment, counterfactual example analysis. And we hope it's just one place for everyone who has either model assessment and model debugging needs or decision-making needs to just go and in a less fragmented experience use all these capabilities hand in hand. So definitely check out our session at MSR Summit on Responsible AI Toolbox.
Thank you, Marouche. Let's go back to the experiments and observational studies for a minute. One thing that we observed during the COVID times is that when we look at the vaccines, for example, the majority of these vaccines were tested in the early versions of COVID. And what we are seeing now is that even though they ran a randomized control experiment, it was very well done. The results that they have from those experiments are not the same results that we are seeing now because the virus evolved and now we are with the Delta variant. The effective rate of these vaccines have changed. Sonia and Mingji, have you ever observed something similar where you have a randomized control experiment, but in Microsoft, for example, but this or in other places, but this the results have changed over time? Is that something that you have observed?
I can't give a specific example, but I think it's definitely a challenge around. We have lots of early adopters and Ring 1 beta testers who use products in development. And I think that there's ongoing challenges for teams that if they do an experiment with those users as to the effects of different features or discoverability of certain features, that those users are going to be different from the general population. And I think that that's a pretty close analogy to the virus evolving, right? If the population using a feature or a piece of software is changing over time, perhaps just because it's growing more popular or being used more broadly, then the effects of things that you tested in one group may not generalize to the whole population.
So I'm coming from Xbox. So it's quite interesting. Last April or March, when the pandemic outbreak, what we see, actually, this is it's not a good news for the world, but it's a good news for gaming because everyone stay at home, and we clearly see from our data we see there is a party chart function feature in Xbox platform. So basically, people can it's voice communication when they play game. So when we introduced party chart in the past, so we just give every gamer a choice. They can communicate if they are on a co-op gaming, so they can communicate, cooperate the multiplayer games. And this feature is not heavily used in the past. It's just if you look at the dashboard, we have a monthly dashboard to track the usage, and it's relatively stable and not peak. But last April, we see this is jumping significantly, almost 1,000 up, 1,000% uplift. So that's a significant uplift. So we start to invest more on the capacity to accommodate the party chart features. But after April and May, so when people used to the new life and stay at home, we see the peak gradually die down. And so that's something you observe event happens, and you start to try to invest more in those events based on correlation or your intuition. But then the event die down, so then your investment probably will not be wise. So that has statistical background. So when we do inference, when we do estimation, you always want to track the population, the distribution move. You want to be mindful on the things you capture. Is that stable? Is that generalizable? And is that evolving with time?
Thank you. Well, going back to the tools, how do you see a lot of adoptions across Microsoft in the tools? Like, what has been your experience on working with other customers in Microsoft?
Very great question. Yes, I've seen a lot of adoption specifically by field teams and sales teams that are interested in understanding how to better support, say, Azure customers and what kind of promotion, what kind of discounts, what kind of treatments to apply in order to make sure that customers are staying with the platform or getting the best experience. So I've seen quite a lot of adoption there. With external customers, there are a lot of HR departments, a lot of sales teams that have traditionally they were using sales forecasting to understand or forecast their sales, but now they would like to use causal analysis on their current data to understand how to use this package and the visualizations that are provided to increase the sales and increase the benefits in the market. And so I see a different kind of set of teams coming to the causal teams compared to the many teams that I was seeing on the model assessment side, which was a lot of teams that were in heavily regulated spaces or heavy machine learning training, etc. And yeah, I'm quite excited to see, although the tool is going to be released officially at MSR Summit and in December, but there is already a lot of adoption on the visualizations and tools regarding causal analysis.
May I ask a quick question? So how easy to onboarding these tools you mentioned? Is that, so for Xbox, we have rich data and we have a lot of unknown questions to be answered. So we would like to leverage these tools.
That would be awesome for us. Yes, so it's quite easy in that sense that our visualization tool is like a wrapper around EconML. So it's literally you pass your data, you pass your type of the problems, their classification, regression, etc. And what it does, and it's a customizable dashboard, so you can onboard different concepts to it. If you want interpretability, you activate interpretability in it. If you want error analysis, so like there are a variety of different capabilities. Causal is one of them. And so you activate causal and you have to pass your treatment features, what features you would like to understand its impact on the real world phenomenon. You have to pass heterogeneity features that you would like to consider so that in the back end, when the causal models are being trained, that's sort of considered. And then it's just via, I would say, 2-3 lines of simple API code. EconML is called out in the background. The causal models are trained, and then you can see 3 tabs, as I said, with aggregate causal analysis, individual causal analysis for individual data points. It also has causal what if, which I'm quite excited about because that was one of the major things that I was seeing people using prediction what if to understand how one treatment would impact. Now we have causal what if, where you can change one feature from a value to another value and see how the treatment would change, how the treatment would impact the real world phenomenon. And then we have the cohort, or I should say recommendation policy, where you can see where your bigger benefit lies. Like what are the cohorts that you should treat, and in what different way you should treat them in order to see, say, the biggest boost in your sales or the biggest boost in whatever phenomenon you're about to impact.
Another important question is the solution scalable? So because Xbox data is very big, very large. So is that a scalable solution?
Yes.
Okay.
It's a very great question. We're also integrating it with Azure Machine Learning to harness the power of cloud in terms of scalability. So in February, also, we are going to release its integration with Azure Machine Learning that will address a lot more scalable problems that users are facing.
That sounds perfect. Let's think offline on this.
Definitely.
Yeah, and Minji, that's the reason I was thinking when I asked the question is like, unfortunately, what a lot of times we're seeing is that there are very cool tools that we develop in Microsoft, but sometimes a lot of people in Microsoft are not using. So I do think that like the community needs to help, and I think this conference should help make sure that other teams are aware of these tools. And to follow up, like have you think about something specific where we can try to convince people to use the tools?
Our strategy always has been open source first. So we release all of our capabilities in the open source, including this new dashboard that I'm talking about is going to be 100% in the open source. And the way that I see it is it's actually perfect for the audience of this conference because they're the thought leaders and researchers, and they can treat that as a marketplace to bring and plug in their own capabilities. And so be a part of that end-to-end responsible AI or in general responsible decision-making effort that we're trying to set up here. And so part of our all of our motivation to go open source has been to be able to collaborate with stakeholders from Microsoft or outside Microsoft and bring the latest and greatest of each team and each community to our packages, and address the fragmentation issue of like onboarding to 10 different tools in one place. And so if anyone is interested, I would love for them to reach out to our Azure, to our Responsible AI toolbox open source and let us know if they're interested in contributing to that. And they'll certainly be quite happy to also get GitHub issues or feature requests and address your needs.
Yeah, definitely. I believe personally, I believe the open source concept, and if we work together, we can make the product continuous improvement. To answer Jen's question, so we do have some burning question right now. So, for example, we want to improve our friend recommendation. We build machine learning model and we suggest a friend to people, and we see people connected when connected through our friend recommendation, but we don't know why they are connected. So our machine learning model leverage deep learning technology, but after that, what we are thinking is trying to put some reasoning tag on each the friend we suggested. For example, you have 6 overlap friends. That's why we suggest these people to you. Oh, you play this multiplayer game with him last night. We suggest these people. So this people is influencer in Minecraft, for example. So there are totally numerous reasoning tag we can put on each of the friend we suggested leverage the model. But we want to understand, okay, this explainable AI, is that really helpful to boost the end user result? That means more people will more likely to connect when we provide the reasoning tag. So such kind of you can say it's a research topic or it's a product real pinpoint. Maybe we can leverage the tools that you have, and once we put the reasoning tag on top of our machine learning model result, we want to evaluate, okay, which reasoning tag is best to give the best performance.
If I can jump in with a question, Marnoosh, you talked a bit about like the risks and the challenges with people misinterpreting interpretable AI as causal. And I'm wondering, as you're creating these tools for causal inference, besides the risk of putting us causal experts out of a job, are there concerns around people who have the very important domain knowledge but don't have the expertise in causal inference around how they're going to use that and trying to help them avoid those pitfalls?
That is a great question, and I personally hope that we never put anyone out of the job and we just empower people. That's definitely our goal. But a very great question. So another thing that we're doing is we are releasing a resource center around these tools to accompany this kind of like toolbox that we're releasing with set of best practices, case studies, and sample notebooks. We're now developing case studies with both internal teams and external teams around causal analysis. You mentioned a great point of there should be conversations with stakeholders and domain experts at what should be the heterogeneity features, what should be the like treatment features that they really want to investigate, etc. And so we're trying to set up some best practices based on the domain knowledge of the EconML team and their previous integrations with customers there. So I'm hoping that will be addressed through the lens of white papers, case studies, and this resource center. But certainly from the people in the community, if there are suggestions as how to make sure that people are not misusing this information further, we would love to be, we're all ears. We would love to apply them to our tools.
Yeah, to echo Sonia, and I think both of us have the same reaction on that. Like when we build tools and now we have a tool that we call it causal and people upload the data and get results, I think the biggest risk is not ignorance, correct? Like the opposite of knowledge is not necessarily ignorance, but the illusion of knowledge is that we are providing the people with the illusion that, that I am convinced that my feature or whatever I'm doing works. And now I have something that is called causal that is telling me that the thing works. When I will not understand basically that, well, likely that is because there's a huge correlation between, I don't know, the users that like this feature also like that feature. Like I have a lot of horror stories on people trying to infer causality, like people not really understanding causality basically, and that's why when we have tools, I do think we need to, similar to like if we look at the responsible AI, some of the websites that you guys have that people need to sign up something and read something between the fine print, like. I do think that if we have a way to have like a small video saying like careful here, careful, like it's something that is simple enough for people to say careful here, like we have to be really careful on trying to infer causality directly, So anyway, these are just, I think tools always help, and I think education should also help, but it's just of course I think we share the concern on people misusing the tools,
Yeah. So to add on that, I think a self-service tool is bridging the gap between product team and research team. Do you guys provide some training session or onboarding session to help people make sure people properly use this tool or leverage the power of it?
That is a very wonderful question. So usually when we release products, we always release with an AI show or with some sort of educational tutorial or material. But I'm also quite active in any data science and machine learning conference that you name, like KDD to more industrial one, ODSC, to NeurIPS, etc. And we try to do hands-on workshops and tutorial sessions to educate the thought leaders and users of these tools. With customers, we actually have a very strong team that partners with customers and brings them up to speed. So usually I start all of these engagements from the internal. So I set up sessions and hands-on workshops with people, the field people, with people who are working closely with external customers or even internal customers and bring them up to speed so that we have enough voices to kind of evangelize the right use of these tools. And then we record videos, we attend the conferences. In this particular case, we're going to accompany the tool with a website with best practices and sample notebooks. So we do everything that we can think of, but I feel like definitely we require a lot of assistance from super knowledgeable people like yourself and other people in the field to kind of like take that messaging further to individual teams as well.
Yeah, and I think one of the things that actually work very well, it would be, my recommendation would be to show things that actually went wrong, basically, where the output looks like one direction when in reality it's not, basically. Like, and I think we'll be more than happy to provide some of those examples. Because I do think that we need to show people, say, hey, careful, there is a risk here, basically. So anyway, well, we are almost over, but if anybody wants to share, like, how do you see, what do you think is going to happen in this space in the next 2 to 3 or 5 years? If you have any comment on the direction that this feels like to me, I'm seeing an explosion on causality, and in many ways, I have to thank Pearl and the Book of Why. In part of this is that we are bringing causality to the mainstream, and I think that's a great thing. But how do you see that the space could grow in the next 5 years?
Yeah, I think explainable AI and also link with causalities is going to grow. I just talked to my colleague when I was in the PhD program. So they asked me what. So they noticed the technology booming, and they also noticed the high tech booming. So they asked me, what research topic? So my friend was in a professor position in statistics department, and she asked me basically, what research topic you think will capture people's eye? So I share my experience to them. I think so. Machine learning is getting very hot because it's automate a lot of things, and it's also increased the efficiency of the product. But the other thing is we need to identify the right feature that when you turn the knob can change the people's behavior. So that's the causality play an important role. Right now, a lot of machine learning is just an automation tool. It's identify the pattern and bring the content, like a recommendation system, bring the content to you to increase efficiency. Next step is basically trying to understand the machine learning model, identify the underlying causality, and identify the right feature such that you can proactively to make some action to move the needle. So that's something I think is a hot topic in the next few years.
Well, I want to thank the three of you. I really enjoy our talk, and I learned more about our tools, and I look forward for collaboration with the three of you. And thanks again for participating today on this panel. Thanks, everyone.